Guys, let's learn all about the structure of Watson and Crick's DNA. DNA structure was attributed to the findings of scientists James Watson and Francis Crick, who found that two strands of nucleotides connecting together form each side of the DNA's ladder and are held together by two groups of nitrogenous bases that hold tightly to each other, A with T and C with G, like the firefighter clenching his hose. The bases are paired together with one purine so that adenine bonds with thymine and cytosine bonds with guanine. The rungs of the ladder are made up of hydrogen bonds reaching across between the two nitrogenous bases. The entire ladder is made up of these nucleotides, which consist of a ribose sugar, a nitrogenous base, and a phosphate group. These nucleotides are the building blocks of DNA, so it's important that you understand all their parts. The components of nucleotides consist of 5 different carbons, each with a different purpose. The 1' carbon is where the sugar connects to a nitrogenous base, like A, C, G, or T. The 2' carbon is what distinguishes DNA from RNA, with DNA having a hydrogen and RNA having an alcohol group bonded there. The 3' carbon is where sugar connects to other nucleotides' phosphate groups, where a phosphodiester bond will be formed between the two nucleotides. The 5' carbon is where the sugar connects to its own phosphate group. The 3' and 5' carbon connecting between nucleotides forms that phosphate backbone that supports DNA structure. Remembering that base pairs are very selective is a huge part of understanding DNA. The base pairs must be connected with their buddies, or the DNA will not work and fires will rage on throughout DNA land. I like to compare adenine and thymine to a wood fire and water. The fire is stabilized and put out safely and effectively when these two pair up. Guanine and cytosine pair up like a grease fire and baking soda, with the baking soda stifling the burn of the hot grease and cooling things down easily. These connections are made stable through the way that they're connected, not with the weak hydrogen bonds that connect like ladder rungs, but through stacks of the individual base pairs, building up a certain way in the nucleotide strand to hold up correctly. These strands are also oriented with anti-parallel strands, or directions, meaning that the nucleotides are connected and read from opposite directions. DNA can be visualized and identified as having 2 different orientations, or handedness. Most of the time, DNA is directed with right-handedness and is with the ladder's sides crossing over the front of the helix, pointing up and to the right. The DNA also has different sections, with there being both major and minor grooves. The major grooves are a lot wider and are most often the site of protein binding because they have the widest gaps and are more easy to access, just like highways are easier for giant fire trucks to navigate than tiny single-car paths. When we add salty, concentrated buffers to DNA, let's see what happens. An experiment using saline sodium citrate buffer solution would show that DNA is manipulated by being strengthened, and its TM, or temperature at which DNA is going to be 50% denatured, will be made higher. The TM being made higher means that the DNA will take longer to be denatured or destroyed. Why does this happen, you may ask? Well, because the salt ions in the solution neutralize the destabilizing negative charges on the phosphate groups that connect to those 3' and 5' carbons of the nucleotide strands, and they become less negative and destabilizing. This makes the DNA and be able to withstand higher temperatures for longer without messing up. Here are my references. Thank you so much for watching, and be sure to like and subscribe.